Okay. I never know if this thing is working until it shows me myself on YouTube and my audio goes crazy. Okay. Welcome everyone to December. It's great to see you. Thank you for joining us. I know we have folks from Toronto. If you're joining us from elsewhere, please jump in the chat. Let us know where you're coming from. Let us know what you're up to. That is how you get connected to this community. So tell us a little bit about yourself, and because we'd love to know. In the corner, or actually in the center of my shared screen, you will see devopsco.slack.com, which is where a lot of us hang out on a regular basis. There's a lot of great conversation there. If you have DevOps related questions, comments, problems, griefs, gripes, controversial opinions, you should be sharing them there. We love to have you. So jump in there, even if it's once a week, to check in on what's going on. There's a lot of valuable brains in that space, and you should check it out. This month we have Patrick Connolly joining us live for the first month as a new community facilitator. He's going to be helping out, connecting us together, finding new and interesting ways to bring this community together, and fun things that we can do to really maximize this experience of being a DevOps community. He's been a part of this from the very beginning. I think, Pat, you actually got me into this initially. I really believe that. He's been off busy elsewhere building communities, but he is now back. Pat, introduce yourself. Tell us a little bit about yourself and what you'll be working on.
Sure, yeah. Real quick, I guess I've organized a civic tech group in the city called Civic Tech Toronto, and there I always describe myself as like an anarchist sympathizer with a soft spot for government. So I kind of like, I don't know, just build a lot of tools for organizing. Yeah, I guess here I'm just kind of trying to bring in some tools that kind of bring back some of the like features of physical space before we can actually get together yet. So just we might be kind of adding on some little trial things like post-event hangouts, which we have one tonight. There's a slide up later. Just to like break from the Zoom format, which is like very unlike real life, is wonderful, you know, as convenient as it is. And yeah, hopefully kind of being a little bit of a peg for organizing just a pub night or something simple later on. Anyhow, that's all. Good to see y'all.
Perfect. Very happy to have you. Appreciate your help kind of expanding the horizons of the community, because I know there's a lot of things that we could be playing around with and we could be testing, and people get busy, and it certainly isn't something that I focus a lot of time on. So I really appreciate that. And I know that you know what you're doing in this space. So that's really cool and exciting. We have sponsors to mention, to which we are very grateful. CloudBees being one of them. They do all things DevOps. You should check them out. They've been sponsoring us for quite some time now. BMC has just recently joined. If you are interested in more operations, data, large enterprise DevOps, BMC is something that should be probably on your radar. And also on your radar should be JFrog. JFrog behind Artifactory, all things artifacts, but also expanding into other areas of CI/CD and pipelines. Want to quickly mention my book, just because I'm always interested in feedback. I'm always interested in folks who've read it. If you have read it, and this is just reminding you that you did read it, I would love to hear from you. What did you think? Did it make any sense at all? Have you used any of the ideas in the book? I would love to hear that. So ping me on Slack, let me know. If you haven't checked it out, it's really quick, and I highly recommend it. with that, I'm going to hand over to Jeremy, who's going to be teaching us how a global pandemic can help us think about DevOps practices. But before I do that, I'm going to mention next month where we're going to be talking about the conflict, the apparent conflict between DevOps and quality assurance. Is there one? What can we do about it? And so you should join us next month. But without further ado, I will hand off to Jeremy, and hopefully you can share your screen as soon as I stop, and take it away.
I will be able
to. So thank you very much.
Yeah, all right. So now let me share my screen. This should be it. All right. So now I still want to see you all though. Hold on. Let's get the way this, look how Zoom, there we go. All right, there we go. I can still see you all. Great. All you beautiful, wonderful people. And let's make you bigger so I can see more of your faces. All right, cool. So here we go. I am going to talk about DevOps and software delivery in a global pandemic, or what a global pandemic can teach you about better DevOps practices. We've been in this thing for almost 2 years. I hope we've learned something. So before I go, too far, I want to kind of talk about and kind of call out the immensely important State of DevOps reports. If you haven't read those, I highly recommend you do. The team there has done just an amazing job. They're highly valuable. They've really helped over the last few years to drive the important practices and behavior shifts in the industry that we've had. I would say the big difference between the report that I'm going to be talking about that we've been creating now, this will be coming up on the 3rd year, and these other reports is that those, they're industry reports, and they're largely based on survey data. And so based in potentially biased by the memory of the engineers who take the survey and who choose to participate. I know my memory is not very good, or I like to think that I'm doing better than I probably am. And often when we take surveys, we kind of fall into that trap that John Allspaw once kind of tweeted, said, work as imagined versus work as done. Or as, we kind of call it performance described versus performance derived. And given that our platform is used to perform many of the activities that get associated with high performance teams, it allows us to measure the actual behaviors that are performed to get a better understanding of how actual engineering work is getting pushed through the pipeline. Like, did they actually push code as often as they claim they did today? And how long are their workflows actually taking, as opposed to what they thought they did? So again, hello, my name is Jeremy Meiss. I'm the Director of DevRel and Community at CircleCI. We are a cloud and on-prem continuous integration, continuous deployment platform for your teams of all sizes. And we just rolled out a full freemium model. So go check that out. All right, that's all I'm going to say about that. At CircleCI, we have massive amounts of unique data on how technology teams, delivery teams behave in the wild. And so this report kind of examines over 2 million jobs per day, or over 55 million data points from more than 44,000 organizations in 160,000 projects. We started looking at all this data in 2019 and started kind of figuring out how we could, kind of get some data out of it, and got some data science people into it. And then then last year, with the whole world changing, we really wanted to see how developers' work was changing. What were the things that they were doing differently now that the way of working was changing? We're not, for the most part, everybody was back at home working. So we don't believe in one size fits all success metrics for delivery. Every team's different. And I think you run into a lot of problems when you try and duplicate what other people do. But the software delivery patterns that we've observed on our platform, especially the data points from top delivery teams, start to kind of show some key similarities that suggest that there are some valuable benchmarks for teams to use as goals. So one of the big things that we kind of offer with a set of baselines for the 4 metrics that tend to be related to CI that we think are most important for a developer teams to track. as far as measuring like velocity and engineering efficiency on teams. And these would differ slightly from, the 4 classic metrics, which are deployment frequency, lead time to change failure rate, and recovery from failure. Recovery from failure time, mean time to recovery. There's a couple different ways of saying that. And so here are the benchmarks that we've identified for high performing CI, continuous integration teams. So they'd be throughput, and that would be as often as, anytime you can, anytime you want to. Duration, meaning that your workflows, your pipelines are less than 10 minutes, that your success rate is more than 90%, and then that your mean time to recovery takes less than an hour. Those are the benchmarks that we've identified. And as we look at high performing teams, what does that look like for their continuous integration metrics? So let's start looking at the data that we have from our report. Throughput on the first metric, it's defined as kind of the average number of workflow runs per day. A workflow is triggered when a developer makes an update to the code base in a shared repository. A push to your version control system like GitHub, Bitbucket, whatnot, triggers a CI pipeline that contains that workflow. So the number of workflow runs indicates how many discrete units of work move through your application development pipeline. The right size of those units or commits is going to depend on your team, but the goal really is to have units of work that are small enough that you can debug quickly and easily, but are also large enough that you're deploying meaningful change, not just pushing a doc change and saying, "Hey, that was a new deploy that counts against our deploys for the day." So we looked at the data between the 2020 data and 2019 and saw that at the 50th percentile, people are triggering CI 0.7 times per day, which isn't really a lot, and it is kind of a dip from 2019. But then at the 95th percentile, it's 32 times a day, and which is a nice jump, 6.5 times more than 2019. But then when we look at the mean value, that really kind of shows us that really your average, the mean value of your projects are primarily sitting at that 8 times per day versus which is an increase from about 6 from 2019. And throughput and deployment frequency are different, and both have been taken as a proxy for productivity, though doing that can be a little misleading. For example, like one thing we don't explicitly measure in throughput is whether a deploy occurred. Even the scenario of many deploy workflows per day doesn't indicate that there's meaningful work that's getting done. You can push small, inconsequential changes to increase that number, but really not have anything really happening with your projects. Most projects just are not really deploying dozens of times per day. They're not even validating their software dozens of times a day. And so while it's not untrue that a description of a high-performing team is one that deploys a lot of projects, it just means that it may be one project that's really moving that fast, but a whole bunch of other projects that they have really aren't doing that. And so looking at the total sample of everything going on within a engineering department versus maybe just that primary main repo. A particular number of deploys per day is not really the goal, but a continuous validation of your code base via your pipeline is, and that's an important thing to remember. It's not about how many, it's about the quality. So duration, we define that as the length of time it takes for a workflow to run. It's the most important metric in that list of 4, because creating that fast feedback cycle, which would include throughput and mean time to recovery, hinges on your duration. In other words, you can't push a fix, even that much needed fix. It's going to bring up US East 1 faster than the time it takes your workflow to run. Duration also represents the speed that your developers can get a meaningful signal, like, did my workflow run, pass or fail? A short duration requires that you have an optimized workflow. So duration is not really an explicit measure of how long it takes. It's just a measure of how long it takes to get to a workflow's conclusion. The ultimate goal of CI being fast feedback, a failed build signal needs to get to developers as soon as possible. It's okay to get a red build as long as you get that quickly and not having to wait an hour for that build to finish and then realize that it's red. So in the 2020 data, 5% of builds finished in less than 12 seconds. So when you think about 5%, that doesn't seem like very many in that sample, but in that large sample size that we have of 55 million kind of data points, that's about 500,000 builds in that sample, which is not really a small number. So then we start to ask the question of, okay, so what actually can you get done in 12 seconds in that short build time? The answer is probably not a lot, but for some, you could do quite a bit. If you have a lot of unit tests that can be parallelized, or maybe you're running a whole unit test suite, if you're uploading an artifact into an S3 bucket to get it ready for deployment, you can probably do that in less than 12 seconds. So 5% was doing, we saw was getting that done about 12 seconds. For 2020, that 50th percentile kind of pegs it right around the 4-minute mark. And so if you're a developer, if you're getting good, like quality feedback in 4 minutes, that really can be a game changer. But when we look at like the 95th percentile, it's about 34 minutes, which is an increase a little bit longer, about 2.5 minutes from 2019. But for a lot of companies, depending on what they're building, that 34-minute mark is probably a good place to be. But what we are seeing is that half of all the builds are finishing in 4 minutes. So yeah, and in the way that all of the durations are going up just a tiny bit, we generally relate that to, as we look through the data, that just means that more testing is happening, which is really a good thing, to be honest. Success rate. So that's defined as the number of passing runs divided by the total number of runs over a period of time. Didn't realize you're going to have math today. As we look at success rate, we're looking at how often does your pipeline complete with a green status. So pipelines can complete with a red, green, or error. Now an error, it just means that it's incomplete. Something couldn't be done. So it could be that an external resource, US East 1, was not reachable, or you were putting an impossible scenario in place, like a test divide by 0, something like that it just was an error. Nothing could be done there. So for us, a success rates at the 50th percentile, we've seen are at 61% of all pipelines are passing in green. But looking at the lower end and at the higher end, you're seeing that there's a group of things that never fail, and there's a group of things that always fail. And so when you throw those out and then look at the data, you see that roughly half of all builds are passing. And what this is telling us is that a lot of people are just testing out projects. They're dabbling with their CI. They're doing something new. You think about how many of us have started up a project over the weekend, started messing around with it. You think you can get it done over that weekend. You don't, and you never come back to it. I know I have. Heck, I have over 20, I think I last counted like 25 domains that are sitting there doing nothing. We really didn't see much of a difference between 2019 and 2020 when it came to, kind of that success rate there. Now, mean time to recovery, that's defined as the average time between failure and the next success. So this is really the second most important metric in the list, because after you get a failed signal to your team, their ability to address the issue quickly is invaluable. Because mean time to recovery improves with more comprehensive test coverage, this metric can be a proxy for how well tested your application is. Like a failed build is a valuable signal, could get to a rapid fix. A passing build, kind of continuous integration, makes these rapid feedback loops possible. The fast signals that we really want to get kind of enable teams to try new things, respond to any impact that might be happening quickly. It's also important to have solid test coverage so that you can kind of reduce that fear of introducing broken code into your production code base, so that you can kind of challenge the engineering teams to be creative and nimble with the solutions they develop because you have solid testing in place. So looking at the data here in the 5th percentile, we see 2 minutes that it will sit in a failed state before it's recovered, which is just under a minute improvement from 2019. A lot of times in those scenarios, that could be from multiple contributions are running in parallel, where developer 1 pushes a bad commit, developer 2 pushes a good commit, bad commit fails quickly, but the good commit comes right in. Or it could be me realizing, oops, I know what I did wrong, push that build up there to be ready to run, but immediately after the other one. Don't even want to look at my commit messages for those. At the 50th percentile, you're seeing about an hour until it's recovered properly, an improvement of 3 minutes. And then from there, you kind of see things that are probably more attributed to some code gets pushed and you go home and come back the next day to check it. We'll come back to that because that's an interesting phenomenon. The mean, though, here is about 14.5 hours, 14.85, which really illustrates that going home. It's about the time that you have the end of the workday to the time that the next one starts. In the 90th and 95th percentile, where it looks like people just kind of go home at that 39 hours, which is an improvement from the 2019 value. But this going home bit is kind of interesting because it kind of tends to go against the whole classic philosophy of you don't go home if the build's red. But there's also some pragmatism here that I think we have to look at, that where when you're analyzing the build, is it the most important? Maybe it's a test build. Maybe it's a feature branch. Maybe you're just working on something, wanted to see if it worked. You're going to go home, you'll come back and fix it the next day. So we're not really going to judge someone's work habits about coming home, going home, coming back the next day and checking on the build, or turning things off and turning it back on the next day. Now, but overall in 2020, we've seen recovery time definitely decrease. And overall, it's kind of moving in that right direction. We're hypothesizing here that it's maybe because more people are home, they're more attentive to what's going on with the code. There's maybe less stepping away from the office for a cup of coffee or, a walk around the block, that kind of thing. All right. So all of that data, as we kind of analyze quickly the report, what I want to move to is now look at kind of the insight that we've seen. And it does kind of go beyond saying that 2020 and even really most of 2021 has been a period of time like none other. We can't look at the data that we've seen between the 2 years without kind of thinking about the impact of a global pandemic. How has it affected team performance? So year over year, we hear in the industry that high-performing teams are deploying dozens of times per day. And while those stats make for great conference talks, the data that we see doesn't really corroborate this metric. We don't see workflows being run at this rate by the vast majority of teams. So the throughput here, if we look at the data from March to May of 2019 on the left, and then March to May of 2020 in the middle, and on the right is our August 2020 data. For many of the percentiles, we saw a slight dip as the pandemic was hitting, and then the maximum was reached in April of 2020. Now, if you think about April of 2020, this kind of makes sense. And in the face of global uncertainty, and so a lot of companies kind of felt it was wise to take the engineering team, shore up their business interests. And so in this case, it kind of seems to reflect that teams began automating as much as possible with the entire workforce going home. We saw a lot more companies start to implement DevOps principles in March and April of 2020 than they had in previous years. And so there's just really a lot of shoring up of core applications that were kind of taking place, resolving bug tickets, issues, et cetera. And so, really April 2020 was kind of that primary lockdown mode in North America and a lot of Europe. And so a lot more code was going into the system. We also saw, a lot more activity happening on the weekends than we previously had been seeing, along with more hours in a day where CI activities were taking place per project, roughly 14 hours a day, where it had been 11 or 12, which can be reflected, I think, if you think about it there weren't any more commuting times. You're at home. You're not sitting in a car or on a train for 2 hours of a day. You're at home. So more activity was happening. It's pretty much been the case that you do more work when you're at home. So before we look at the duration data, there is kind of a caveat here. So having workflows with the shortest possible duration is not the goal, like I mentioned earlier. So for example, the shortest 10% of workflows that we measured by duration finished in under 30 seconds. And while this may provide adequate coverage for some scenarios, The 30 seconds is not really enough time for robust tests to be running. Tests are what provide you with a rich understanding of any of those failed workflows. So your test coverage and the signal that provides should be your primary goal. Once you have your test coverage, then you can optimize for shorter duration. So we believe the duration is the most important metric, and we're not interested really in speed alone. So the goal is confidence and quality, which comes from testing. All right, so with duration, we saw the mean kind of was falling heading into the pandemic, and it kind of stays steady, but the 50th percentile and above, the duration increased year over year with a slight dip in April, and then it increased again August towards the longest duration year over year in August. So that typically kind of is indicative of what we see is businesses starting to shore up the business. They're starting to get more tests. We see that in the suite of people doing more testing, more fine tuning. They're working on their pipelines more. And the key here is we often get the question, what duration should your team aim for? In our experience, durations between 5 and 10 minutes are going to be short enough to get information quickly, but yet long enough to give your team the valuable insight that they need when a build fails. If you go shorter than 5 to 10 minutes, it means your feedback generally is probably not going to be complete, and you counterintuitively increase your time to recovery because you're not really testing and getting the insight you need. Longer than that 10 minutes, and you tend to lose the attention of your developers. While you're waiting on long tests, nobody wants to just sit there and wait. So they're going to go and start working on other work. And then forgetting to come back, and then your failed state goes up. It all kind of moves together. Success rate. So the importance of success rate can be variable depending on the structure, size of your team, what's being worked on. If a branch represents one person working on a topic or feature that no one else is relying on, if there's a red build, that's less concerning if no one else is working on it. But on the other hand, if the entire engineering department is blocked from doing work until the main branch is green, then if you have a preventing red build, that's going to take top importance. So our data set kind of included workflows from both of these scenarios, and then kind of everything in between. Success rate, we look at the 50th percentile. There are some things that are always green, some things that are always red. What we see with this uptake and success rate for the 50th and 60th percentile is about the same year over year. It kind of ticks up again like all the others in that kind of April timeframe, and then it goes back to being about the same. And this tends to show the typical kind of red to green type of development cycle where you're testing out new features. Does this work? Does it work? Good. And moving on. We shouldn't expect every commit to be perfect every single time. A healthy and innovative engineering team tends to have somewhat of a high degree of failure, and that's okay. It's the failure on the production branches that's more important than the failure on your development branches. But we also kind of see a peak about the same time that the pandemic was kind of kicking in. That signals that with the average engineering team, they're likely doing less innovation and more shoring up of the core business, resolving issues, bugs, etc. So when you're resolving those bugs, you're going to go from red to green until you get that stability in the system. So we would expect to see a peak in success rate here because you're getting just more of that stability. But once it's stable, success rate's going to go back down. You see more innovation or new feature branch kind of development happening. This lower bar at the very bottom, the red that kind of trails off towards the end of the last year, signals people are starting to test out more automation tools. And when we looked at the data, that's what we were seeing is more testing as they're understanding, okay, we need to get this better. We're also seeing that also in your feature branches, whatnot. There's many ways, when you think about success rate, there's many ways to get to a failed build. There's many ways to fail. There's really only one way to get to a green build, and that's for it to be successful. So if you have something that's failing, you you could push another commit, it could fail, and you can push another, and you do this consistently. But then that sixth one kind of is a success. And so if you think about it, like a 1 in 6 success rate, which is what we are seeing kind of trailing off here at the bottom of the data. So the hypothesis, success rates were basically the highest on record. Is in one of the thoughts here as we looked at it from a data perspective is that there was less distraction for many developers. Weren't going to conferences, there wasn't traveling. They started working on all of the software and core business instead of going and spending time at the water cooler. Success rate can be an interesting statistic, but it isn't always indicative of bad process or performance. I think that's important to hit there. All right, so finally, mean time to recovery. The recovery time, the fastest, we're on an order of like a couple of minutes. And so once again, it goes back to the shortest time possible isn't necessarily the gold standard that we're trying to get to. One way to kind of get a fix this quickly would involve a developer knowing that they just submitted bad code and then immediately pushing a fix while the original workflow is still running. It's one way to game the system if you're measuring the wrong things. Alternatively, it could also indicate that 2 developers had pushed the commits minutes apart. Kind of talked about that earlier. So what we've seen with the recovery time, and it kind of follows the same basic path from the other metrics, is that they're declining. In the 95th percentile, we're seeing that year-over-year drop, but a big drop in April to May. And that generally reflects that if stability is the business's ultimate goal, especially with those commits that you're pushing during this time, it's going to be reflected in the data. And what we've seen in the early stage of the pandemic was kind of this all hands on deck mentality. Everybody possible, get in there, resolve issues, and get that signal back as quick as possible, mitigate the issues, and so on. And so feedback, we all know that feedback cycle is at the heart of CI and kind of that rapid app development process. Okay, so the signal clearly shows that we had more developers pushing code and fixing issues, et cetera. They had less distractions like going to conferences, travel, et cetera. And everyone's back on, they're trying to get stability, they're working on what's important for business. But I do want to stress that just because you're at home, and I think we all hopefully have come to this realization, just because they're home does not mean that there aren't distractions. They're different, but they're still distractions. And so, it's important to take time for yourself. What the data has shown us is that some people were able to do more while at home, while others were able to do less, and that's okay. So it's important to set targets. This slide, I will share out the slides to be able to kind of see some of this, but this kind of just breaks down what it looks like from some of the suggested metrics to what the median developer using CircleCI through the data was seeing. Some last little things here around some of the interesting tidbits. Success rate on default branch was higher than on non-default, which kind of makes sense. You're only pushing things to your default branch when it's ready to be rolled out. And so expecting, the success rate on those branches was 80% and 100% for the 75th percentile and above. So it just kind of tells us that a lot of innovation is happening on non-default branches than before, because at the 50th percentile, it was 58% success rate for default branches. So a lot more innovation happening in that default kind of get flow method using the default non-default branches. Another thing we saw is that duration on default branches was faster at every percentile over non-default branches, which again kind of goes back to this idea that the mainline branch is the most important. So you make sure that everything is going to pass and everything's functioning the way it should, so that the feedback you're getting is good. Recovery time was lower on default branches at every percentile. Again, it's the same thing. People who are relying on mainline, they're watching the recovery time a whole lot more, making sure that fewer people are impacted by a red build. And this just kind of tracks with the things we continue to see. And then some development practices that really work and really kind of showed us that success rate, just because you have a lot of developers or a lot of contributors, in your GitHub org, or you have 4. Success rate did not correlate by your organization size, the number of developers working, which was really interesting. But what we also saw with that is that the duration was longest for teams of 1, which makes sense. If you're a team of 1, you aren't really a team, number 1. And secondly, you're not really going to care if it takes you a long time to get feedback, because there's no one else waiting on you. But it also shows that if there's that social construct, that if you have someone waiting on you, then you're going to want to make sure you get that up. So the duration was longest if there was only 1 person, shorter if there was more than 1. Same thing with recovery time. It decreased the larger the size of your team. But what we also saw is up to about 200, we didn't see much. There wasn't a lot of data to see with larger teams that were over 200 that were all at once in the same repo. So up to about 200, we were able to see that your recovery time is going to be the best. It's going to decrease the bigger the team you get. So in summary, like, we know that performance is always going to be better if there's more than 1 contributor to a code base. And you're better with you, and if you have more people than you working on whatever thing that is, which again, software's collaborative. I think we know this, but I don't think we talk enough about the fact that you need more people looking at your code. You need more people coding together to get to a quality state. And you're going to get better outcomes if you have more than 1 developer working on a thing. The other thing, don't deploy on Friday. It's not a thing. The data doesn't show it. Like, you see it come out on Twitter, like Jackie's laughing. You see it out on the Twitter space. Don't deploy on Friday. It's not a thing. It's ridiculous. Go deploy on Friday if you have the proper stuff in place. It's going to be fine. The data bore it out. There was 70% less throughput on weekends, but there was only 11% less on Friday and 9% less on Monday, meaning people are still deploying, and it's normal. And if you, again, put these processes in place and have good code coverage and testing and all of that, it'd be fine. Couple of sneak peeks into the data that's going to be shown. Was this December? End of next month or 1st of February, we'll have the new report out. But right now we're seeing in the data that workflows with 0 tests increased year over year, but they decreased as a total number of all workflows. So really what that's meaning is that, we're seeing people, more people are deploying with good testing than before, which is an increase. We're also seeing that more people are deploying as part of their process in CI. That goes from CI and now it's going to a deployment. That's increasing. More people are working towards that continuous deployment piece, and so change validation, really is becoming necessary. We're seeing that. Also, in the latest DevOps report that just came out, again, I highly recommend you check that out from the DORA. The 50th percentile of folks that on CircleCI make it into that elite performer. And so this what this tells us, it's not about CircleCI as much as it's about the people that are using us are fitting into that elite performer status versus those that aren't. And so it's a good little piece around the industry. You can go and view the full report here, circle.ci/SSD 2020, or the QR code. You do not have to sign up for anything. You're not going to get an email from me unless you want one, and you'll be able to view the whole report. The new report is coming out, like I said, in the next month and a half, and there's already some really amazing things popping up with that. So I definitely kind of keep your eyes open for that. And the last bit, feedback and swag. I'd love to get feedback from you. Head to circle.ci/Jeremy or circleci.com/Jeremy, and just let me know your feedback and or any questions you might have, or just cut straight to the swag request. That's fine too. I understand, and that's okay. But you can find me on I am Jerdog on Twitter. I write not as often as I want to on Dev2, and then also LinkedIn and such. So thank you. Appreciate it. That's that.
Thanks, Jeremy. That was great. My first question is, where did Jerdog come from?
So I'm a little bit of an old. I'll just say it that way. I started using bulletin boards back in, before the internet, quote unquote, existed, even though it existed, but before www existed. I was on the internet back in the 80s. And so I had been looking for a nickname or a handle, an online name. And a friend of mine, for some reason, instead of saying Jeremy, he continued to say, Jerdog, what's up, Jerdog? And eventually I was just like, okay, I'm just going to use that. And so I started using it, and then was like, okay, it fits. It's fine. And then like fast forward 30, almost 40 years, 35 years. We'll go 35. Fast forward 35 years. And I'm like, well, I'm stuck with it. No sense in changing it now. So I just have stuck with it.
I hear you. I love an origin story, especially one that goes pre-internet.
Oh, yes.
So can you give us any hints about what's like, have you seen the data from the 2021 survey?
I've seen some of it. And so some of it was there with the, the more and more people doing testing, the last, bits. There's also seen more and more Kubernetes actually is growing in use. And we're seeing that more and more as people are integrating Kubernetes into their pipelines and into their workflows, is becoming more and more of a thing, which is good. Infrastructure as code, we're seeing that be a growth point. So those are some of the things that are starting to kind of make their way into the report.
Cool. Are you guys getting this data from? You might have mentioned, but I might have missed it. Are you getting the data directly from Circle, or are you getting it through surveys? We're
getting it directly from the data in the platform.
Got it.
So not all anonymized data, but it gives us actual real data instead of like a survey.
Cool. Does it show you, like, do you know if there's any way to find out if there's people using Kubernetes as like a platform as a service, or if they're like rolling their own? Because I'm super curious about that.
I would be super curious on that too. We'd have to, I don't know that we could dive that deep into the data unless we looked for specific.
You kind of have to find out if there's like, because I guess you guys would know what files are present in the repos, right? So like,
yeah, we would have it. We would have
if there was like a manifest file.
Yeah, right. Like we'd have to search manifest file. We'd have to search. There'd be a wide variety of things we'd have to look for. So I'm not sure that we would have that. It'd be an interesting study though, for sure.
I would expand the question on Kubernetes. I'm wondering, are there any data showing what CI/CD pipelines are being used for Kubernetes?
Let me see here. I had a couple notes on that. No, I don't have that specifically yet. I don't have that data. Tell you what, while I have you, let me check one thing. I have language data. I have search real quick for Kubernetes. No, I don't have that full data yet.
I would be really curious. So, like specifically, what I would like to know, Kubernetes native pipelines versus any other pipelines.
Yeah, that would be interesting. I'm sure I'm sure some of that will be in there.
You're welcome to wildly speculate in the meantime.
I'm welcome to. I don't know that I'm going to.
It's definitely not necessary.
Yeah.
Jackie asks, are there any other interesting data points or insights that you came across that didn't make it into your talk?
Actually, there are. Let me pull up my slides again. There's a, see if I can find the window with this when you're using multiple windows. Oh, come on, DevOps 2.0 Toronto. There it is. Let's see if I have it here. There is some software related metrics that is interesting. If we have time, let me go ahead and just share these. Get this back out
We
here.
got a few minutes.
Okay, because this was really interesting from a language perspective. No, I don't want to share it. I want to slideshow it. Zoom is hard. I'll be glad when I don't have to do this anymore. Okay, share the screen. There we go. Okay, so when we were talking about like throughput, the top languages, 1 to 20, being the best in throughput, down to the not as much being pushed. Ruby and TypeScript is kind of leading the way in terms of throughput, and that kind of suggests that like developers are using smaller batches of work, which fits with kind of the languages, and that they're using CI more often than some of the others. What's interesting in here, like HTML, Dockerfile, the Dockerfile one's an interesting one. We started to see Jupyter Notebook start to appear more in the the data around the different software languages. The success rate. So you have Vue, CSS, Shell, Dockerfile, top 4 or 5. Those are the high success rate. There is generally, like, we're seeing that's more indicative of like not many tests happening, as most of those languages or text files, there's not really known for having a lot of test robustness, but they're also likely steps. They likely have steps that are kind of producing artifacts and output as part of a larger project. From there, we kind of see like Go down there 8 leads the way when it for success. After you get through those languages, and then most of the rest of these kind of tend to be some dynamic languages. At the bottom, you see the compiled languages. So likely because build and test steps for each of those languages are a little bit more involved than you would kind of see. But Go is kind of an anomaly here of the success rate when it breaks down. Go developers are actually monitoring their pipelines better than others, which I don't know if that's indicative of the Go platform or Go developers. I don't know. But then we see groupings kind of here of you have dynamic languages and then combined languages. Like there's just or compiled languages. You just see some groupings as you go down this list. Recovery time for some of these could be slower because duration for them is also slower to get to a build. And then it also just could be that some languages are just have more complicated workflows. So you have some that, easier to get to a faster, time to resolution. And then the last one was like the shortest duration. So languages with, that have few build steps, like Shell, HCL, CSS, HTML, like those don't have a lot of build steps. So they're going to be finishing first. Like Shell scripts just run and exit. There's not really a lot of robust testing that you do there. But again, like JavaScript and Go kind of showing up here very favorably in terms of duration. So those were some of the other findings that I didn't get to. So
very cool. All right, Jeremy, I want to thank you very much for sharing. This was a lot of data that I hadn't seen before, and I love data because otherwise I'm too tempted to speculate about things all the time. So this is really helpful. With that, I'm going to
slides. You can find my slides on that link there. I'm going to get this uploaded. So, later today, you'll have the full slide deck will be in there.